If we compare the time of his existence to the antiquity of our Earth, man in the universe just recently emerged. There have been several natural catastrophes in his environment throughout the years, which have left their mark on the planet's current form. However, meteorite falls, of which there were a great deal on Earth, are the most devastating procedure. Imagine finding out at some time that a massive asteroid is heading our way. What effects do you suppose its impact might have? And how does the location of the biggest meteorite to ever strike our planet appear today? Cosmo, we must first comprehend the precise terminology used by science to describe such celestial entities. The name asteroid first originated at the beginning of the 19th century to characterize star-like points seen through a telescope that resembled disks rather than planets. Due to this, up until 2006, asteroids were frequently categorized as tiny planets, with a minimum diameter of 30 meters serving as the primary distinguishing characteristic. Meteoroids are celestial bodies that are smaller than this. The term meteorite refers to space objects that hit the surface of the Earth or another major celestial body after burning up in our atmosphere. In its ultimate state, the majority of them range in mass from a few grams to several tens of tons, and on average, such a large number of meteorites, whose combined mass is close to 2,000 tons, fall on our planet every year. In essence, meteorites travel at a speed of around 50 kilometers/ when they approach the atmosphere of the Earth. We can see their heating and shining as a result of this quick action. The mass of the meteorite that reached the surface might be significantly less than the initial ones because of the burning and blown off by the speeding stream of particles. And if we're talking about really small celestial bodies at speeds more than 25 kilometers/, the item will burn virtually without leaving any trace. However, if a meteorite does manage to penetrate the Earth's atmosphere, the direction of the fall will shift because the horizontal component of the meteorite's velocity is lost when it slows down to overcome air resistance. For instance, if a meteorite first falls horizontally, it may then virtually vertically descend as a result of braking. At the same time, the meteorite's brightness in this instance dims as the item drastically cools down. However, if the celestial body still collides with the surface of the Earth, this is known as an impact event. The impact site often forms a crater, but there is also a chance of a fire, an earthquake, or a tsunami. Truly catastrophic processes can result from impact events, and some hypotheses contend that numerous mass extinctions were brought on by meteorite collisions. When such an object collides with the surface of the Earth at a high speed, a significant amount of energy is released along with strong explosive processes that create a crater that is considerably greater than the meteorite's own diameter. For instance, it is well known that the 1.2 kilometer diameter Arizona crater formed around 50,000 years ago, after the collapse of a 300,000 ton, 50 meter long cosmic object. Similar to the bombs dropped on Hiroshima, the explosion it caused when it landed had a similar explosive force to that of 8,000 atomic bombs. Such falls can create whole rocks through a process known as impact metamorphism. Some mineral deposits are connected to them, like the copper and nickel deposits at Subboard crater. Meteorite craters may be up to 500 kilometers in diameter, and some of them even have their own towns. For instance, the South African crater at Raid Fort, which has a circumference of up to 300 kilometers, is called after the settlement that sits inside it. This is 1.3 times bigger than the Subboard Basin and the Chicxulub crater by comparison. The Earth collided with an asteroid with a diameter of around 10 kilometers more than 2 billion years ago, causing the formation of this object. Given that it is only a few 100 million years younger than Jarvi, which is 2.4 billion years old, Reed Fort is regarded as the second oldest crater on Earth. Aside from the 500 kilometer diameter Wilkes Land crater, which is hidden beneath the Antarctic ice sheet, the object is also the biggest crater. Most likely, a collision with a meteorite of a diameter of around 60 kilometers caused Wilkes Land to develop. The age of the crater was first unknown to researchers, but more recent studies have shown that it is around 250 million years old. The Permian mass extinction, which resulted in the demise of 96% of all marine species and 73% of terrestrial vertebrates, was most certainly brought on by an impact event of this size. This explanation still cannot be regarded as proof, however, because the crater's position makes it difficult to investigate. A lot of celestial bodies fall on our planet with far less force than others, and not all meteorites can create enormous multi-kilometer hollows. For instance, although the Goba meteorite did not produce a sizable crater, it may nevertheless be said to be the biggest alien body ever discovered on the surface of our planet. The item, which weighs 66 tons, is the biggest chunk of naturally occurring iron on Earth. The meteorite has a 9 square meter volume and a 3 meter diameter. Approximately 80,000 years ago, Goba crashed to our planet. In the African Republic of Namibia, close to the settlement of Fruitfontein, it was first found in 1920. The finding was made entirely by chance. Goba did not leave behind a crater or any other signs of its descent, and this may have been due to an atmospheric deceleration. The item also has a smooth, flat surface, which is unusual for most meteorites. Goba is a thick metallic mass that is composed of 84% iron, 16% nickel, and a trace amount of cobalt. Although the weight of this meteorite has never been measured, it is estimated to have been around 90 tons at the time of impact. At the same time, it is also astonishing that Goba did not seriously harm our surface. After all, the position of the fall is usually the determining factor in the fatal outcomes. For instance, the meteorite that is said to have been responsible for the claimed extinction of the dinosaurs is said to have fallen in the shallow seas of the Okutan Peninsula, which at the time were gypsum stone creation sites. As a result, a significant amount of gray matter was released into the atmosphere throughout the fall, which signaled the beginning of a protracted period of global winter. The highest quantity of dust entered the atmosphere as a result of the ancient item falling at an angle of around 60 degrees, and the impact itself produced a tsunami that was about 80 meters high. Because of the global forest fires brought on by the high-temperature shock wave that swept over the Earth's surface, as well as the resulting climatic change, the planet's surface was shielded from sunlight for several years by a dust cloud. A fact given how infrequently huge meteorites fall, there is extremely little chance that such a collision will take place in our time. However, there is currently no method for humans to defend themselves against such a threat. For instance, 1950 DA is one of the most hazardous asteroids that is heading toward Earth. The closest tiny object to Earth with the greatest Polarmsky Collision Danger Index. The asteroid will reach the Earth at its closest point in 2032, and there is a 1 in 300 chance that it may collide with the planet in 2080. In this scenario, the collapse of human civilization is predicted to have disastrous effects, including the alteration of the climate and the extinction of a sizable portion of the biosphere. The mass of 1950 DA is still unknown, despite having a 1.3 kilometers diameter. Asteroid Bennu is regarded as the second most potentially deadly cosmic wanderer. In 2135, it will be just 300,000 kilometers away from Earth. The potential fall date ranges from 2175 to 2199, since Bennu will pass quite close to Earth 78 times during this time. However, there is a 1 in 4,000 chance of an asteroid impacting Earth. The asteroid's mass ranges from 60 to 78 million tons, and its typical diameter exceeds 510 meters. The detonation of a bomb with a force of 1150 megatons in TNT equivalent would be the effect of this item on Earth. Comparatively speaking, the Tsar bomb, the most potent explosive weapon ever used by mankind on Earth, had a force of around 58 megatons in TNT equivalent. It seems conceivable that science will soon discover a method to alter the course of potentially hazardous celestial bodies coming towards us from the far reaches of space. People can only pray that an impact event with such devastating force won't happen again on Earth anytime soon till that happens.